Greetings, everyone. Welcome to E&E Learning Hub. Today, we're going to be looking at question 1 from the 2017 CSEC Electrical and Electronic past paper. So let's begin. So part 1 of A, it says state two effects of an electric current. So two effects are magnetic effect and the chemical effect. So those are two effects of electrical current. All right, so that's it for part 1 of A. So for part 2 now, it says describe the following materials and give an example of each. So the first material, a conductor. So a conductor is a material that allows current to flow through it easily. An example, copper. All right, so that's it for conductor. The next material is an insulator. And this is a material that does not allow current to flow through it. An example of an insulator would be rubber. All right, so that's it for part 2 of A. All right, so let's move on to part B now. So it says figure 1 shows the circuit diagram of 3 resistors connected in series to a 12-volt DC supply. So here we have figure 1. So we have 3 resistors, R1, 6 ohm, and it have a voltage drop of 6 volt. R2, 3 ohm, and for R3, the value wasn't given. And the 3 resistors are connected in series across a 12-volt DC source. All right, so that's it for figure 1. So part 1 of B, it says to calculate the current flowing in the circuit when switch S1 is closed. All right, so let's close switch S1 here. All right, so now that the switch is closed, we now need to calculate the total current flowing in the circuit. Now, looking at the circuit, we realize that R3 wasn't given. So it means that we cannot add up all the resistors together to get the total resistance and use that to calculate the total current. Now, remember, for a series circuit, the current is constant, right? So it means that if we were to go at this point here in the circuit, or this point, or this point, or this point, we will get the same current value. So we can use the values for R1, and that is the 6 ohm resistor value and the voltage drop, which is 6 volts, to calculate the total current, because the current is constant or the same throughout the circuit. So it means that IT is equal to VT, not VT, but V1 divided by R1. And that is 6 volt divided by 6 ohm. And that will give us 1 amp. And that's it for the total current flowing in the circuit when switch S1 is closed. All right, so let's move on to part 2 now. So it says to calculate the total resistance of the series resistors. Now, we have calculated the total current and we were given the total voltage. So it means that we can now calculate the total resistance. So therefore, RT is equal to VT divided by IT. So the total voltage is 12 volt divided by 1 amp, and that will give us 12 ohm for RT, and that's the total resistance for the circuit. Now, for part 3 of B, it says to calculate the resistance of resistor R3. All right, so we know that to calculate the total resistance for a series circuit, and to be more specific for this circuit, RT is equal to R1 plus R2 plus R3. All right, so based on this formula, we calculated RT, and we were given R1, and we were also given R2, but we don't have R3. So it means that we will now have to rearrange this formula to make R3 the subject so that we can calculate the resistor value for R3. So what we're going to do now is that we're going to bring over R1 and R2 to the other side where RT is. And remember, when you bring over positive values, they will now become negative. So therefore, R3 is equal to RT minus R1 minus R2. That will give us 12 ohm minus 6 ohm minus 3 ohm, and that will give us 3 ohm for R3. And that's it for part 3 of B. All right, so let's now move on to part C. So it says, draw a schematic diagram to control an electric lamp in a stairway by a switch on top and another switch on the bottom of the stairway. All right. So the first thing that we're going to do is to lay out the switches and the lamp. So the fact that we're going to control a lamp at the top of the stairway and also at the bottom of the stairway means that we're going to use 2 switches. And in order for us to control the lamp from 2 different positions, we will have to use a single pole double throw switch. All right, so let's lay out the switches. Now, also to note, when drawing schematic diagrams, they should be drawn in their de-energized state. All right, so that's something to keep in mind at all times. All right. All right, this doesn't look too bad. All right, so here we have our switches. All right, so keep in mind that this is not, drawn to scale. All right, so let's put in our lamp. All right, good. And finally, we want to add our symbol for the source. All right, and there we go. And here we have our schematic diagram, so we can also label it. So the lamp is called at L1. For the switches, for the first one, let's call it S1. For the second one, let's call it S2. And for the source, let's call it VS. All right, so that's it for this question.